All right, so here we're going to go through a number of the multi-choice questions from 2016 VCAA exam. So we're going to start at question 2. The variables are blood pressure, low, normal, high, and age, under 50 years, and then 50 years or over are. All right, so quite a badly answered question, this one. It's quite easy to first recognize that the first variable here being blood pressure is ordinal, low, normal, high. That's definitely ordinal. So remember, ordinal, as the name describes, basically has an order to it, increasing in value or increasing in something. A very common mistake here would say the next part is nominal. However, it is technically also ordinal. The reason for that is it increases, in this case, by age, but it's still a categorical variable. It's categorical because we're categorizing people as either under 50 or 50 and over. And it's ordinal because there is an order to that. We're increasing from low to high. So the answer for that one is B. They're both ordinal variables. So if there is some sort of order to it, which in this case there is, that's what we classify it as. So question 7, there's always usually one question around this. In the question before of 6, there was a graph, but there was some really huge differences between the charts, between the bars. Therefore, often it's plotted on a logarithmic scale or a log scale like this one. What that does is it essentially scales it down, so it's a bit easier to interpret the graph. Based on this histogram, the number of countries with one or more billionaires per million people is. All right, so one or more, that's this section here, increased over 1. So the number there is 1, once you look at the scale over here. So A would have been a pretty common incorrect answer, but that's the log value. We need to interpret that. You can use the solve function to do this. So log 10 of the number is equal to, in this case, 1. So what you would type into the CAS is solve. Log base 10 of whatever the number is, that's what we want to solve for, is equal to 1. Because we have 1 as a value there. If there was 5, then we'd put in equals 5. And then we're solving for x. You plot that in, you get 10. So just to show you that on the CAS, in case you can't remember where the log function is found, over here you go, so we'll say solve first, control, and then that 10 to the power of x. We have a log of base 10. We were solving for x equals 1, solve for x, and we get x equals 10. So the answer is E. So pretty much always in further, we always have with a log base 10 value. You might get a different number if they want to try and throw you, but the only difference there is if this was log base 5 or whatever, you would just change the 10 there to a 5, but it's pretty much always 10. Parallel box plots would be an appropriate graphical tool to investigate the association between the monthly median rainfall in millimeters and the something else. All right, an important thing that you need to understand about box plots is that what they do is they compare a numerical variable with a categorical variable. They do not compare two numerical variables. That is a scatter plot. If you have two numerical variables, what you get is an axis that looks like this with your dots. That's your scatter plot. But if we've got a numerical variable with a categorical variable, that is where we use a box plot. So we can use that logic to essentially answer this question. Wind speed, that's numerical. Temperature, that's numerical. Sunshine time in hours, numerical. Rainfall, numerical. Has to be C because that is the only categorical variable there. What you do is on your axis, you'd have your months or whatever. You wouldn't. You would have your rainfall and how many mils, blah, 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 whatever. And then you'd have one box plot that represents January. You could have another one that represents February, and so on. But you can't have these as numerical values. It doesn't make any sense. So make a note of that. Parallel box plots must compare a numerical with a categorical variable, not two numericals. Question 10. In 2011, life expectancy in Australia was 81.8 years and the Human Development Index was 92.9. When the least squares line is used to predict life expectancy in Australia, the residual is closest to. All right, so if you remember all the way back to that, the formula for residual, we say, is the actual value minus the predicted. Now, typically with these, we're given the actual and then we have to calculate the predicted. So the predicted is where we use the least squares regression line. So the actual, in this case, was 81.8. That's given to us. So now we need to work out the predicted using the least squares regression line from the question. So I'm just going to scroll back to get the equation. All right, so the equation was life expectancy is equal to 43 plus 0.422 times the Human Development Index. All right, so what we can do now is work out the predicted life expectancy. 43 plus 0.422 times the Human Development Index, which was 92.9. You calculate that, what you get is 82.2. So the residual is the actual, 81.8, minus the predicted, 82.2, which is negative 0.4. So the answer is B. Question 22. The first three lines of an amortization table for reducing balance home loan are shown below. The interest rate for this home loan is 4.8% per annum compounding monthly. The loan is to be repaid with monthly payments of $1,500. All right, so we've got a table here. We've got a balance of $250,000, so we can see that here. And every month the payments are the same. So we only see the first two, but when you continue these on, they stay the same. And they're always whatever the interest is plus the principal reduction. So this will change from month to month, these two values here, but they always add up to 1,500. So we can use that information to calculate the interest and therefore the principal reduction. All right, so the interest paid will be whatever the balance was, which in this case, the balance beforehand was 249,500. So you just take whatever the previous balance was. Now we need to calculate the interest. The rate was 4.8%. So as a decimal, 0.048. Now it's important to note that this is compounding monthly, so we need to divide that by 12. Calculate that. What you get is 998. So that's the interest calculated. So that was quite a common incorrect answer to say that the answer was E, but that's because that's the interest. This question wants the principal reduction. So you can pretty easily work that one out because the principal reduction and the interest have to add up to 1,500. So that's 502. And lucky last, may invest in an annuity that earns interest at the rate of 5.2% per annum compounding monthly. Monthly payments are received from the annuity. The balance of the annuity will be $130,784.93 after 5 years. After 10 years, it'll be $66,000, blah, blah. The monthly payment that she receives. All right, so this is definitely a finance solver question. And it's a pretty tricky one. There's a lot going on. We only do need to do the finance solver once, which is handy. We don't have to do it multiple times. Whoops. CPY and PPY will be the same. All right. So what we can do here is we can work out essentially using this as our starting point and this is our end point, we can work out what the payment will be. So what we're going to do is we're essentially going to use the 130,000 as our present value where we're starting from, and our future value will be the 66,000. So let's start by putting those in. Now it's annuity, so our PV will be a negative. Oops. And our FV will be a positive. So our payment we don't know. Our interest will be 5.2. This is all monthly, so 12. And then N, a few people would probably make a mistake on the N value. We're essentially starting at the 5-year mark and we're ending at the 10-year mark. So we're a 5-year period we're looking at this question. And because it's monthly, it'll be 5 times 12, which is 60. So it'll be 60 payments in that time. All right, so now we have those values. We can plug them in and we can calculate. So let's have a look at our finance solver. What are you doing me? So menu, finance solver. Ooh, it feels like it's been a while since we've done this. It's 60, 2, negative 130,784.93. Payment we don't know, 66,992.27, and PPY is 12. And remember, whenever you change payments per year, it automatically changes the CPY. Enter, and we get 1,500, pretty much bang on. So the answer is C. All right, hope that clarified a few things for you. Please shout out if you want further help.